Welcome to this new episode of My Data Guest. So today we are going to continue this wave of episodes on how to build AI agents with a specific tool. And today we will talk about how to build an AI agent with CrewAI. And for that we invited Alessandro. Hi, Alessandro.
Hi, thanks for having me here at our podcast. How are you?
All good, all good.
Ready
We already
to learn
had
everything.
a few of these episodes, so...
Yeah, ready to learn everything about agentic AI.
I'm ready.
Yeah, but we did the recording with Miguel, so now I feel the pressure and I'm like, okay, I have to do...
Yeah, before there was Martin.
Yeah,
So yeah, there
there's
are
a lot
some...
of pressure on me now.
A bit, yeah.
Anyhow, I'm talking about a different topic. It's still agentic AI, but we will dive into a different framework, which is CrewAI in this case. If you know me, if you're following my work, you probably know that I was contributing a bit to this package. So I am a bit biased, but it's not the only framework that I'm using. Definitely is one of my favorite, together with Landgraph. What's interesting about CrewAI is that it doesn't really replace the other frameworks, but you can use it together with the other frameworks based on the problems that you want to solve. Without wasting too much time talking about the frameworks in general, maybe I can already show you a couple of slides that I prepared for you today. Okay, so this is a very short presentation. It's not supposed to be a TED talk, but just a couple of slides to guide me through some of the concepts that I want to show you. We will try to start from scratch, Rosaria, so you will be a CrewAI expert afterwards. What do you think?
I'm looking forward to it.
So the idea is that I want to introduce this topic starting from the basics. So why we're talking about agentic AI. And I think the best way is to start talking about LLMs. A few years ago, not too many years ago, LLMs, the first huge LLM was released to the consumers thanks to OpenAI. And essentially when we use an LLM, we start from a query, we generate something, and then we get an answer out of it. And everything is based on the fact that we have this large language model that is trained against a huge amount of data. And then we move to compound systems. Compound systems are basically RAGs. So one example is the RAG. The RAG is used to solve a specific class of problems. Essentially, every time we have an LLM that cannot really answer your question because it doesn't have the information that the LLM needs inside the training data to answer that question, it is able to access this retrieval, thanks to this technique called retrieval augmented generation, is able to access some sort of database that is used to augment the answer that is given to the user. One example is, let's assume that the LLM has to answer something about your calendar. But of course, the LLM doesn't know anything about your calendar because the LLM has been trained against some data where you don't find information about your calendar. Then the LLM can access this external database where we have the information about your calendar in it and then answer this question thanks to it. And then the third step, if we can see it as third step, is agents. At some point, we started using the LLM as thinking unit process. So we have the LLM under the hood that, thanks to this huge amount of data that we have, thanks to the training step that produced this LLM, thanks to all this information, we can use the LLM to think about what to do next and to think about more complex tasks. And we do that thanks to external tools and thanks to some sort of loop thinking process that we have around the LLM, where we don't stop at getting the output of the raw output of an LLM, but instead we think about this output. It's like thinking 10 seconds before saying something. And then thanks to this thinking loop, we decide what to do next. Think of something, maybe if you think about this process, it's even more clear. Let's assume that the LLM gives you an answer, but that then you don't know if that answer is actually what you need, because thanks to an external tool, you see that there are more information that can enhance your answer. Then you use again the LLM to say, hey, that was my previous answer. What can I do next thanks to this new data? And then you decide what to do next. So this goes more in the direction of agentic AI. And another really important pillar to understand before diving into the framework is the difference between prompts and agents. If you think about a prompt like this, research top 5 electric scooter brands in Europe, compare the features and prices, then write a full marketing strategy for a new scooter brand and include a visual concept. This is a very complex prompt, even though it's kind of short. If you don't have an agent that is taking care of some of the steps here, some of the branches that you will create with this logic, most likely you will have an answer that is not really solving your problem, is not really giving you the right answer. And the problem is that you have multiple steps. Some of them are supposed to be deterministic, so you want them to be deterministic. And if you take this prompt and you create multiple steps and you split the prompt into multiple tasks, and then for each task you ask the LLM what to do, then you are going in the direction of agents. Because essentially, if you split this into multiple tasks, then you can have one agent that is taking care of one part of this problem. Then you can have another agent called competitor analysis that is comparing results, another agent that is taking care of the strategy, and another one for the design. So this goes more into the direction of splitting complex tasks into simpler tasks, and then be sure that you have some sort of you have a sort of deterministic process happening under the hood. And then now we can move to the framework. With CrewAI, what we gain by using a framework like this, as well as LangGraph, is that we don't have to care about implementing things like reasoning or concepts like agents and tasks, process, because we have these concepts implemented under the hood. And the beauty of these frameworks is that we only have to focus on the problem that we want to solve. So we don't have to waste time understanding how to implement the reasoning process with an LLM, with Python or C. We just use an interface that is telling us, hey, this is an agent, this is the task, focus on the problem that you want to solve, and then we do the rest. And another important thing is that every time we use frameworks like this, they are essentially LLM agnostic. So if you want, you can also move to a different LLM and everything works out of the box. So if you want to base your solution on OpenAI, you can do that. But if you want to move to OpenRouter, Claude, whatever, you can easily do it. All right. So what CrewAI looks like under the hood? Essentially, CrewAI is, so the most important unit is the agent. But in addition to it, we also have the tasks. The tasks are essentially what the agents are going to work on. And then based on the process that we choose, which can be a process that let the agents work with some sort of hierarchy on top of them, or maybe they work on tasks in a parallel way or one by one, depending on the problem that you want to solve. Then we have the tools, which is one of the most important concepts when we talk about agentic AI. The tools are essentially things that can be used by the agents. You can see them as Python functions essentially, or APIs, whatever you want to give to the agents. It's a way of making the agents more powerful and give them, I don't know, like legs or arms in order to let them do things that they were initially not implemented to do. One good example of tool can be giving the agent the possibility to browse the web. So maybe the agent doesn't really have this capability, but if you create a tool that is letting the agent to browse the web, like getting the HTML content from the page and then feed it into the LLM, then you have the capability of browsing the web. And then in CrewAI, we put everything together around this crew. The crew can also be seen as an agent, because the crew is putting together all the components that we create for our application. And then the crew in the end, as we're going to see in Python, is our interface to this new application that we're building. And one important topic, which when I have workshops or go to conferences, is that there's always like a huge gap between understanding why the frameworks does specific things and how you should translate your problem into something that is actually doable with that framework. And one of the most important concepts is that you have to keep in mind that you're building a team. So when you write something, when you try to implement your solution with CrewAI, what you're actually doing is implementing a team of agents. So you have one that is turning goals into tasks. This can be called planner agent. Then you have a content creator agent, API caller agent. And it's the same concept of building a team of people. So if you want to build a team of people, then what you do is you look for a team leader, you look for a data scientist, a machine learning engineer, and so forth, so on. And the idea is that you have a team with different capabilities that are going to work on different tasks, but towards the same goal. All right, now we can dive into the actual package and the interface that we have in CrewAI. So the first one is the agent. If you want to create an agent with CrewAI, what you do is simply importing the agent from CrewAI, from the CrewAI package, and then you have to specify the role, the goal, the backstory. With the role, you are telling the agent what the agent is about. The goal is not what the agent is going to do, but it's more about what's the goal of this agent. I usually get this question, what's the difference between the role, the goal, and the backstory? Well, the role is I'm a data scientist. The goal is, my goal as a data scientist is to create the best machine learning model ever, but I'm not telling you what I'm going to do or how I'm going to do it. And the backstory is essentially an extension of the goal. So my goal is to build the best model ever, but my backstory is I have 10 years of experience in data science, and I'm really keen into something specific, and I have a lot of knowledge about, deep learning model for price optimization and so forth. So this is how we should see these three fields. Here you can already see that we have a clear separation of things that kind of collapsing together every time you write a prompt. Because when you write a prompt, you try to put all these things together. And usually the way you start writing the prompt is always like, you are a data scientist with 100 years of experience. You're going to work on these tasks because this is the goal, and so forth, so on. Here we have a clear separation between this. And there is one thing missing, which is, of course, what the agent is going to do. This is something you can do with the task. So with the task here, we have the possibility to tell the agent what to do exactly. And until the slide before, we didn't tell the agent what to do. So now we describe what's the task of the agent, which agent is going to take this task, and the expected output. The expected output here is a very powerful thing. I'll show a couple of examples, but essentially with expected output, we can be sure that we're going to get the output in a specific format. Let's assume we want to get a JSON. We will get a JSON. We can also use pydantic, so to force some sort of validation against the output. And this is a very powerful concept, which is something that is always kind of failing every time you write a prompt, especially if that prompt is part of a pipeline that can eventually break. And maybe that step where you have a prompt is giving you a JSON, but sometimes the prompt, since the LLM is not deterministic, won't give you a JSON. With this, it's a deterministic way to be sure that you always get an output in a specific format. And then finally, once we have the agent and the task, we put everything together into a crew. Putting everything together into a crew means that we get to the point where our application is essentially done. So we create the crew object, and then we specify the agents, the tasks. Here we have the tasks that have been already assigned to these agents, the type of process, so how the agents are going to work together. In this case, the agents are going to work on the tasks in a sequential way. Before the research agent creates something, that is going to be given to the writer agent. And then some other information regarding the output, and verbose is essentially something that I use to make sure that the output has a lot of details for debugging purposes. And now we can also dive a bit more into the process. Essentially, we have two main ways of letting the agent work together. The first one is sequential. It means that, as I said before, they're going to work on the tasks one by one. The second one is hierarchical. When we use hierarchical, which is a very powerful type of process, we have another agent, which is called manager, who is going to work on top of the existing agents and make sure that they're going into the right direction. Is very useful whenever you want to write an agentic application where you have some sort of fixed constraints. Let's say that the agents are going to plan your trip, but you have the constraint of not going above €300 as total budget. In this case, you can use a manager, which is a special type of agent that is going to essentially look at the work of the underlying agents and deciding if what they're doing is also respecting the main constraint, which is about staying below a certain budget. And finally, we have the tools. The tools is writing a tool in general in agentic AI is one of the most important things because it's about giving superpowers to the agents. So the agent is not able to browse the web, maybe, but if you want, you can write a tool that is giving this superpower to the agent. These capabilities are usually things that belong to the business, to the business domain you're working in. In this case, I'm using the Serper Dev tool, which is a very famous tool already provided by CrewAI. That means that you have a lot of tools that have been implemented already and are provided by CrewAI. In this specific case, I'm using a Serper Dev tool, which is already implemented and is not a custom tool, it's provided by the package. And I'm giving this tool, as you can see, to the agent. So when I create the agent, I use the field tools to provide a list of tools. In this case, I only have one. And then the agent, whenever we will call this application, we will run it, it will be able to browse the web thanks to this tool. If you want, you can do even more. You can write custom tools that are used to create things that have not been implemented by CrewAI. Let's assume that you don't want to browse the web, but you want to do more. You want to browse the web, but then you want to take out some contents containing violence. If you want to create your own tool following CrewAI instructions, and then you can give it to the agent. We will see a small example later. And this is the end of the boring part, because now we can look into the code. And here I have essentially a couple of examples that I presented a few months ago at a workshop. Essentially, these are assignments that I created for a workshop. And if you want to dive into these assignments, if you want to do these assignments yourself, you want to solve them, you can go on my GitHub and we will also leave a link about this because this workshop is still online. Maybe I can even find it. Let's see. Yeah, it is. So it's here. So if you want, if you're really brave, you can come here and have fun with these workshops. The
But we don't
solutions.
see them
No,
because you're sharing only the slides.
let me share this
Otherwise, we can provide that
here.
later.
So if you want, if you're really brave, you can come here and have fun with the workshop eventually. And yeah, so here you have everything about how to set it up, how to set up your machine, and the description of the assignments and so forth, so on. All right, let's go back to the code. I think I have to share. Okay, now I'm sharing the code. Okay, so here, this is essentially the repository of the workshop that I just that I was showing a few seconds ago. And now we're going to look into our first CrewAI application. So here I'm creating a very simple prompt, which is doing some prompt optimization, or I'm creating a really simple agent, which is doing some prompt optimization. And this is essentially what happens. This is just an exercise, but this is essentially what happens every time you use ChatGPT or these commercial LLMs. So when you talk to that ChatGPT, what you send to ChatGPT or even better, what you send to the LLM is not the exact query that you wrote in the chat, but instead there is some query enhancement happening under the hood in order to improve your query a bit before sending it to the LLM. And also there are also some other reasons why this is done. And essentially this is what we're doing here. So we want to create an agent that is taking a prompt and then improving the prompt for the target LLM. Let me show you how it works. So first of all, what we're going to use from CrewAI is agent, the agent class, the task, the crew, and the process. And what I want to do here is to create two separate agents that are going to be part of the same crew at the end. One agent is in charge of improving the structure of our prompt, the prompt that we want to send to this hypothetical LLM. And the second agent is the LLM optimization specialist. So once the first agent is done improving the structure of the prompt. Maybe I can also increase this a bit. How is the font, Rosaria?
Actually, that's a very good question. Maybe we can make it a bit bigger.
So this agent, as I said, is about optimizing what we get from the first agent, and then is returning this enhanced prompt. So it's not really sending a prompt to the LLM. This agent is doing a work for us. So the goal is to give to this agent a prompt and then have this prompt back as optimized prompt. So let's have a look at the first agent. So here we have this prompt structure agent. The role is prompt structure expert. We give it a goal, we give it a backstory. And once again, we're not telling the agent what to do here. We're just shaping the agents. Then we have this LLM optimization agent. Still, we use agent, and then we define the role, the goal, and the backstory. These are two separated agents, but until now, nothing is happening because we have to create a crew. To create a crew, as I showed before, we have to use crew, but before, we have to define the tasks. I'm putting everything into a simple function here for convenience, but essentially what we have in this function is the two tasks that we are giving to the agents. So we have the structured task. This task is for the prompt structure agent. And this task has the information about what the agent has to do. So here in this task, we are basically defining all the instructions for improving the structure and the clarity of the prompt. Here we have improved the structure clarity of this prompt. And in this string, we're basically passing the prompt, which is something that we pass to this function for convenience. This will be our prompt. And then we say, make it more descriptive and so far, so on. And we give it a set of instructions. And then this is the task that we are giving to the prompt structure agent. As expected output, we want an enhanced version of the prompt, blah, blah, blah. This will be essentially a string. We don't have to do much about this, but keep in mind that the output of this task, which means the output of this agent, will be the input of the second one. So will be the input of this task. The second agent takes this task, which is all about using the target LLM, the target model, which can be, for example, OpenAI, the output that we get from the previous agent, which will come from this task, and then providing a final optimized prompt ready for use with the target model. And here we have a couple of instructions for this task. This can also be shorter, longer, it really depends on you. For the sake of this exercise, we don't want to make it very complex. And then we put everything together because we have the agents, we have the tasks, we put everything together into a crew. Here we have agents, tasks, process, and inside agents, we have the two agents that we have just created, the tasks, structured task, optimization task, and the type of process. In this case, we want to work on the tasks one by one. Why is this important? Essentially because we have two tasks, and the output of this task will be the input of the second one. So we want to execute the structured task, which will create the first draft of the prompt, and then we want to give it to the second agent for the second task. And this concludes the application because now we just have to call it. So here I have a very simple main where I'm calling the get crew, which is in the end creating the tasks and calling the crew that we have just seen. And inside I'm passing a simple prompt, write a story about a robot. And then the target is GPT-4, our target LLM. Now we can try to execute it. Okay, so we execute the assignment number one. Okay, so now the assignment number one is what we have just seen right now. And now the interesting thing is that we're not only looking at the final result, which is kind of pointless because in the end we will get a prompt for that is an enhanced version of this simple prompt, which is write a story about a robot. But what's interesting is the log. When you execute the CrewAI application, you get this very interesting and useful log. We get a lot of information about what is happening under the hood. Don't forget that this is a simple application, but when you have a lot of agents sending tokens to the LLMs, you need some visibility under the hood. So you need to understand what's going on. And for observability reasons, this log is going to be your best friend whenever you run an application like this. Here is basically telling us what's going on under the hood. which agent are being called, and what's the output of each agent. And then you know that it's calling a specific task and which agent is working on that task, and so far so on, up to the final answer from the LLM optimization specialist. And finally, we get our prompt, which is this one, because I'm printing the result. And this prompt is the result of enhancing this very simple prompt. And as you can see, we get a lot of instructions. It's really, really long. I will never read this. And yeah, this is the final output of this application. Do you have questions, Rosaria, or feedback about this?
So I was watching the instructions, which is the interesting part of this whole thing. So basically it moves from your simple prompt to a more structured prompt. I saw that there is, for example, the name of the robot that you didn't give, did you?
Yeah, no.
And then it moves to the instructions that are like even more details for the prompt. So can you comment on that? I think that's the interesting part because...
Yeah, I didn't put too many constraints in it, so it is kind of being very is providing a lot of extra information that I didn't provide, also because I didn't put many constraints. But
that's the interesting part, right?
Yeah, this is very interesting. Don't forget that this is one of the things that can be really complex to do with a single prompt against one single LLM. And the interesting thing is that here, let's go here, we have two agents. So the first agent doesn't really know anything about the second one. So the first agent task, the first is to create, starting from our simple prompt, is to create clear instructions, proper context, specific requirements, and that's it. And what's interesting is that the second agent will take what we get from the first agent, and it will enhance it more, but without interfering with the instructions of the first agent. So basically you get two powerful tasks combined together, and that's why you get so much information. Also, as I said, I'm not giving any constraints, and also you get a lot of tokens as an output. And this is something very complex to do with a single prompt, because usually if you give too many instructions to a prompt, at some point you will lose track of what you want to do. And this is the reason why you get these very powerful models like Claude, the last Claude, I don't remember the name, that are on paper really powerful, and it can give you back a lot of tokens, huge amount of tokens. But if you try to write a book with this prompt, they will fail. They can potentially do it, but they will fail to give you a book, because they will lose track of what they want to do. Even if you give them the best prompt, they will lose track at some point, the context. Even if they can keep that huge context, they will lose track, because you need to go back to the initial part of your book. You need to understand if you're respecting the index, if you're going out of track in one specific chapter, maybe you need to take some actions, and how do you take actions? So that's why with agents you can create a separation, and you have a more deterministic way of controlling what's happening under the hood. And this is what happens here. The beauty of this approach is that the task number one doesn't know anything about the task number two. And if you want, you can create some sort of awareness with this process hierarchical, but basically they will still be two separated tasks. So you will make sure that this will be accomplished.
So there are two separated tasks because of the process that you have chosen, or they are always two separated tasks?
So first of all, because of the process. So this is a very important point. But the second is also, even if you use process hierarchical, there will be some awareness of what's going on. So maybe one agent knows what the other agent is doing, but there will still be two separated tasks. So there is a more deterministic way of solving a problem, still with the uncertainty that you get with the LLM. But yeah, they're still two separated tasks, which is literally impossible to do with a prompt against one LLM. Maybe we can also have a look at the second assignment, which is also very interesting. So with this one, I like this as an example, because even though there's a lot of things that you can check about CrewAI, but there's one thing that I'm really big fan of, which is flow. With flow, we're definitely introducing more complex concepts, especially because we're using some some new stuff from Python, Pydantic, some typing, and so forth, so on. But the beauty of this, of Flow from CrewAI, is that you can create some sort of guardrails. So you can create a way of controlling the flow of your agentic AI application. So imagine that if something, especially in this case, if I want to create some content and that content contains violence in it, and imagine that we're doing this for the My Data Guest posts on LinkedIn. Let's say we want to automate something and we want to write the posts with an agent. What happens if that agent is going rogue and it will start creating content with violence in it? Well, with Flow, you have a way of creating a sort of loop around these agents and then decide what to do based on the output of one specific agent or task. If that agent is creating something that contains violence, or maybe you're not happy with it, you can evaluate that and then you can decide to take a different action. I'm showing you this very quick. Here we have our flow. Essentially what we do with this is, especially this task, is all about creating and validating content with safety guardrails. And the guardrails are about checking if there is violence in the content that is being generated by the agent. It's really good for creating guardrails, essentially. So we create a topic for a target platform, which can be LinkedIn. So the topic is a post. And then we start generating. So we generate our content. We create an agent, and this agent is a content creator. So here we're creating a very simple and small CrewAI application. So the CrewAI application here is composed by one single agent, which is in charge of creating the content, and one single task, which is, the task in this case is create a content about something for LinkedIn. And then once we generate this content, we don't take it and post it, but instead we use another agent thanks to this validate content function, and this will be automatically called because we're using this. So these decorators that are provided by CrewAI. So we're not really into creating the whole loop branches, but instead we are using something that is provided by CrewAI to control this kind of interactions that we have between the agents. So once the first agent is creating the content, then we move to the second one, which is the safety moderator. The safety moderator takes as input what the other crew did and check if there is violence in it. It's the only task of this agent. Why is this better than putting everything in one single crew? Because eventually one can say, okay, why are you creating two different crews? Why don't we put everything into one crew, and you say one agent is in charge of creating the content, the second is in charge of checking if there is violence. It's because I want to do this check as many times as I want. So I want to be sure that if I want to do this check 3 times, this is a deterministic decision. And I want to be sure about this because if something goes wrong, if this is a very critical topic, I cannot trust the LLM, which is still the thinking unit process of the agent that might also hallucinate. I don't want to trust the LLM 100%. So I want to make this deterministic. So that's why I'm using the flow. So the second agent is a safety moderator and is in charge of checking what the first crew did. This crew will give us the final answer if this content is safe or not. The beauty of this now is that if the content is safe, we can essentially post it. If something goes wrong, we can essentially move to this if then else, where we check that if it's safe, we can post it. If it's rejected, what we have to do up to 3 times, we go back to our initial crew here to regenerate, and we regenerate the content. And we do this as many times as we want. In this specific case, I'm doing this 2 times. These are the attempts. And of course, there are some decorators, but this is a simple thing to implement, but of course there are some concepts in it. But essentially what happens is that there are 2 crews which don't really talk to each other, so they're kind of separated, and one crew is checking the content of the other one. And we do this in a very deterministic way. So the second crew tells us if the content is approved. If it's not approved, we regenerate the content. If we cannot regenerate the content up to a maximum of 2 times, like this example, we just return the message, hey, we cannot generate the content. There is no way I can do it, which is the really powerful feature of something like this. Because with an LLM, you will never get this answer. If you use a raw LLM, you always get an answer, right? There is no way that the LLM will tell you, I don't know. We know that it can, but not in that way. If something goes wrong, the LLM will not be able to say, no way I can do that. The LLM is made in a way that you always get something. It's a probabilistic model. You always get something out of it. And that's what we're trying to avoid here. If this content cannot be generated, we will try to make sure that we cannot generate it 100%. Yeah. What do you think about this approach?
So basically, by detaching the two crews, so by making one crew independent, the guardrail crew independent from the other crew, you add one more level of guardrail. You guardrail the guardrail.
Yeah, you make them independent, and it's something you want to do because when you use flow in CrewAI is a way of controlling the flow of the outputs of the crew itself.
Yeah, so you force the control to be independent.
Yeah, you put some controls in it. And I wanted to show this example because it's one of the things that people ask me more often, how to create guardrails around the LLMs, how to make sure that the LLM is doing exactly what I want it to do in a deterministic way. Because of course, if you use the LLM, it's because you need it. You have to solve a problem that it's a bit fuzzy, of course. It's about text, it's about creating text, but it doesn't mean that you want your application to fail if the LLM is hallucinating. So you want to control that thing. Yeah.
Also because when you ask something to an LLM, you don't know the answer, otherwise you wouldn't ask. But
Exactly.
if you want to control it, you know what you want to control. You know what the topic of the guardrail is.
Yeah. And this is another point, is that sometimes, often, to check the output, the correctness of the output of an LLM, you need another LLM. That's also one of the things.
There was some time ago, there was a post of somebody saying that you build guardian agents around for other agents.
Yeah, right. This is what it is. I mean, that's the only way. How do you make sure that the output of an agent or an LLM is correct, while when the first reason why you wanted to implement it is because you cannot do it by hand, probably. So you need to automate that process. So yeah, it's a classical chicken egg problem. Maybe the last thing I can show is a proper application. If I can find it, let me find it. So this is an application that I made some time ago, which I also presented during my last workshop, which is the final assignment of the workshop website I was showing before. Let's see if we can run it. Okay, let me switch the window. So this application is a Streamlit application that I created with Python, of course. The UI is coming from Streamlit. So essentially is a Pythonic way of creating web applications, simple web applications, but with a lot of nice components. And under the hood, we have an agentic AI system implemented with CrewAI. What this application does is simply helping you with interviews. So it's an AI mock interviewer. You select the company, the position, and the difficulty level, and then you start the interview. You can even use the voice. So if you want, you can also talk to it. Thanks to, I'm using OpenAI. I don't remember the package, but essentially I'm using a package for doing the transformation from voice to text, text to voice. So if we start the interview, it will look on the web for the information about this company, and it will create the first question. And while the first question is presented to us, which as you can see takes a while because it's the first question, under the hood there is an asynchronous function still implemented with CrewAI, which is running another crew, the same crew, for the follow-up question. So while we have been given the first question, while the first question is presented under the hood, the second question, the follow-up question, is being created. And this is because we want to avoid this waiting time, which only happens in the beginning. And is also a good example of how to use the CrewAI asynchronous functions. All right, design a simple shortening service. Let's say use a dictionary. Okay, this is of course a kind of wrong answer because it's too short and it will probably expect more. So now you get a feedback from our interviewer. It's evaluating the answer. And then once you get the feedback, see, okay, well, correct, no, and then you get a feedback, you already have the second answer. And this process will keep going until you decide to stop it. And this, I know that this looks like a very complex web application, but it's not. The Streamlit code is kind of simple. You can check it on GitHub. And under the hood, I'm using pretty much all the concepts that I was showing before from CrewAI, plus these asynchronous functions still from CrewAI. Yeah, this is a more like interesting example of how to create an agentic application. Or
Nice.
if you have questions, we go back to this, Rosaria. I saw that you were really interested.
No, they were all very interesting. This one, yeah, we didn't see the code, so maybe I don't have the questions. But it was, I learned a few things today, so I am very happy.
Yeah. Maybe for those who are really interested in the code base of what I was showing right now, can give you a very quick overview, but then they can continue on GitHub.
I think we have a bit of time.
Maybe we can. So if you check this repository, you will see that there are two files. One is the chatbot UI, where I have all the packages that I'm using for creating the actual web application. So this is 100% Streamlit. Here I have all the things for creating the sidebar, sending the message, the welcome message, and so on. But this is Streamlit. It's not really part of the episode today. Maybe it will be one day because it's a very powerful package. But the core of the application is the interviewer practice system. Here we have essentially the agent that asks the crew the process. And as we saw before, we also have a tool. In this case, we're giving the separate dev tool to the agent, which is a tool that will allow this agent, which is the company researcher. So every time we give the name to the company, that this agent will look for information about this company and is able to surf the web. So it's going to look into the web page about this, is going to actually create queries about this company, in this case Google, and then use this information inside to answer whatever this to provide information about this company. Then we have the question preparer, which is preparing the question, the answer evaluator, which gets the answer from us and it will evaluate it, the follow-up questionnaire, which is pretty much what we have for the question preparer, but it will be called under the hood as an asynchronous function. Then we have the tasks, company research task, question preparer task. As you can see here, we have all the information that we were providing from Streamlit, the company name, the role, the difficulty, all given to these agents. And then we have the real kind of topic of this application, which is the fact that we are essentially creating this asynchronous crew, which is this one. This asynchronous function, if we go to the main, so if we scroll to the main here, this asynchronous function will be called under the hood here every time a new answer, a new question is provided to the user. And we want to do this because we don't want to block the execution, but we want to every time create a follow-up answer. So every time we want to call this crew under the hood and say, hey, give me the follow-up answer, which has to be different from the previous one. And we continue this process until we decide to stop it. So yeah, it's not too complex. In the end, we're talking about less than 200 lines of code, plus there is a web application. So feel free to check this repository on GitHub. And fix it if there are issues.
Okay, perfect. I think we have reached the end of this podcast, of this episode. So thank you, Alessandro. I have learned a lot today. I think our audience has learned as well. And thank you to the audience, as usual, for listening to us until the end. We are going to provide the URL for I think you didn't have it in the slides, or did you?
We will provide everything.
We'll provide everything.
Okay. Yeah.
Perfect.
All right.
Thank you and bye.
Thank you, Rosaria. Thank you. Bye-bye.